So here we're looking at prime factorisation and using it to find LCMs, least common multiples, and GCFs, greatest common factors. So basically we'll be working with the prime numbers 2, 3, 5 and 7, maybe sometimes 11. But in general you'll find these prime numbers can factorise most other numbers. So the first thing you need to do is understand that a prime number is a number that can only be divided by 1 and itself. So there we have the most common ones we'll be using, and next we'll look at a factor tree, how to basically break any number up into a product of prime factors, break it up into multiples that are composed of prime numbers. So here I've got the example of 72, and I've broken it up into 2s and 3s. And you need a systematic method of doing that. You always start, first of all, by trying to see if the number can be divided by 2. So, can 72 be divided by 2? Yeah, 2 times 36. Then you work on the 36. Can 2 be divided by 36? Yes. Oh, sorry, 36 be divided by 2? Yes, 18. Then break up the 18. Can 18 be divided by 2? Yes. Now when you get to 9, you'll see that 2 no longer works. So what you do there is you go to the next prime number, in this case 3, and see if you can break 9 up with 3's. And of course you can. 3 times 3. So 72 could be written as 2 times 2 times 2 times 3 times 3. That's a product of its prime factors. Okay, so what we'll do now is see how you can actually use that to find the LCMs, the least common multiples, of two numbers that look very challenging at first. So here we have 72 and 28. Now if you're asked to find the least common multiple of those two numbers, that could be quite daunting. But if you break them up into their factor trees, you can basically just use the largest factor tree of the two that contains both numbers. So what I'm going to do here is I've broken 28 up into 2, 2, 7, and as long as I use a group of numbers that can contain both of these, for instance in this case 2 times 2 times 2 times 3 times 3 times 7, now as long as this can contain both of these in here, it essentially is a multiple. And if I just use the smallest number that can contain both of them, I've got the LCM. So I know it's 504 because I've got my 2, 2, 2, which is enough for 72. I've got the 3 2's covered there. I've got my 3, 3 covered there. 2, 2 I've already covered, so I've already covered the 28 with the 2, 2, 2 for the 72. So I'm really just missing the 7. So really I just have to add on a 7 to this factor tree here, and I've got the LCM of 504. You can also use factor trees to find greatest common factors, and what you're doing there is looking for the smallest number of prime numbers they have in common. So here you've got 2, 2 on 72, and there you've got 2, 2 on 28. So you'd know there that the greatest common factor of 72 and 28 would be 4.